So what happens if instead of looking at the tail like we were in the last problem, we're looking at the centers? How do the centers compare? So let me change this right here to working with, I want 800 to 1100 in this particular problem. There it is right there. That's the center. And I'll find that probability in a second. Oh, and I changed, by the way, so it make it more clear. This was for n equals 1. This is for n equals 30. So when I copied them into the graph, there they are. All right. So then I go back. All right, now I'm going to have to copy this. So let me do this, copy that graph. But I don't want that particular function. Hold on, I'll be right back. There we go. So hopefully that makes sense to you. I made them checkerboards to make it a little bit more obvious. So, I mean, look how much of that graph for the blue one is underneath that. There's only this little bit of white over here. Whereas the purple graph's got tons that isn't in there. So let's look at the probabilities and how they change. And I'm just going to, I'm going to kind of use the same idea here. But it's going to be norm dist, excuse me. All right, now how does this work? It's 1100 minus, now if you're working with a calculator, you don't have this much difficulty, but this is how Excel does it. So you have to do the right hand one, which was 1100, minus the left hand one, which is 800. The mean is still 1,000. Oopsie, 1,000. Standard deviation is still 200, and it's true. Look at that. Okay, so the purple one is 0.5328. Let me write that down right now. This is for when n equals 1, it's 0.5328. Okay. All right, now what about if it's, I'm just going to, because I'm a wise person, I'm going to copy and paste this in. Okay, so what changes here is instead of 200, it's 200 divided by the square root, SQRT, of 30. Or if you like, you could just type 36.5, because we already figured this out, but that's okay. Why not use the calculator's capabilities, computer's capabilities? Okay, check it out, 0.9969. 99.69% of that blue curve, the really tall one, the one for n equals 30, 99.69% of it is between those two values. Almost none of it, just that little bit over here is not in there. Whereas for the other curve, when n equals only 1, because it's more spread out, only 53% are in there, right? That means like 47% of people taking this test score higher than 1100 or lower than 800. Let me go back. Let me copy and paste that in so you can see it. Now let's just think about this for a second. What we're saying here is that, look, we're talking about having an average be between 800 and 1100. Well, people, single people, there's only 53% of them are going to score between 800 and 1100. But groups of 30 having averages between 800 and 1100, that's much more likely, right? It is much easier for a group's average to be around the mean than for an individual. Individuals are all over the place, but groups, because they're random groups, are going to average each other out, which means you'll have a much higher probability of a group being around the center than having a single person be around the center. Okay, so that's the central limit theorem's implications for us, for probabilities. They're going to change a lot. Now, what we're doing here is a lot of Chapter 7 stuff. It's just that the standard deviation changes depending on what your sample size is. And when it changes due to your sample size, that has implications for what the probabilities are going to be. Always keep in mind that groups want to average out and be close to the center. They don't want a lot of spread. That's why the standard deviation shrinks for groups. All right, I'll see you here next time for the next video.